Hey guys, welcome back. Here comes the fun part where we do multiple choice on limits and continuity. And these questions actually showed up on the past AP calculus exam. So let's take a look. Okay. The first question is going to ask us about the limit as x approaches infinity. So once again, this is what we call an end behavior. We want to know what happens as we go out really far in the x-axis. So what we need to do for this problem is very simple. You grab every single x in the parentheses with the coefficient, okay? And then you do the entire reducing thing that I showed you guys in one of my videos. So we have 2x in the first guy. We have negative x. Do not forget that negative. In the second guy, we have x and x. This actually gives you negative 2x squared over x squared. So this actually reduces to negative 2, and I'm going to choose choice B. Okay, so that's what we do in limit as x approaches infinity. Highest on top, highest on the bottom. In the next problem, we see as x approaches 0, what happens? Where does this limit go to? Okay, so we're going to plug in 0. We notice that we get 0 over 0. What we want to do is factor. So we're going to take out an x squared in the numerator. You're left with 5x squared plus 8 over. You're going to take out an x squared in the denominator. That's great. You're going to be left with 3x squared minus 16. So you go and you cancel the x's. You resubstitute the 0 into the remainder. Okay, and then you're left with 8 over negative 16, and that's negative a half. All right, so once you get 0 over 0, you're going to factor. Next problem has to do with basically continuity. So let's take a look. This is a piecewise defined function, and I did a few videos on this. But remember that this is the function for every number except for 2. So that means even numbers of 1.999 and 2.0001. Okay, so at 2 is going to be something totally different. So we're going to have to factor this. Okay, so we get x minus 2, x plus 2, all over x minus 2, and then we cross these off. We substitute the 2 back into the remainder, and you get 2 comma 4. Remember that there's a whole at 2 comma 4. Okay, now in the second part of the piecewise defined function, this guy, had they put a 4 right there, then the function would be continuous. But right now they have 2 comma 1. So this graph actually looks something like y-intercept of this. You get to 2, 4, and then all of a sudden you're going to have, you're going to have something down here and 2, 1. And so there's a hole in the graph, so it's not continuous. Once it's not continuous, then it's not differentiable. And I know we haven't discussed derivatives yet, but that's something for now to take with you. But the limit does exist at 2. The limit is actually 4. So only 1 works, okay? I hope that makes sense.